Hey, if you are preparing for IMAT, this lecture is going to teach you each and every single concept for periodic table. Before moving on to the lecture, try to solve the quiz below, that is the past paper quiz that we will be solving in this lecture at the end of this lecture. And most important thing, this is not going to just teach you concept that IMAT will ask, but it will give you whole analysis of all the IMAT past paper, what they were asking and what they can ask you in your exam. So try to be attentive and try to learn and make some notes, each and everything. So here's the lecture.
We are going to start. What we are going to start, we have got a pretty good periodic table here. Okay, we have got a pretty good periodic table, and we are going to start. We are going to talk about periodic table. We need to discuss in really detail. The thing here is not important because you guys know about periodic table. The thing that you guys need to know is what kind of questions IMET will be asking. So we really need to get those. The periodic table, in periodic table, we have I might ask different way of questions. The first thing, okay, you guys need to remember the trends are really important. I hope I have like picked, okay, the past papers, all of those who have solved the past papers, I have picked the questions from recent past papers, 2022, 2023, and 2024. I didn't go for older papers because I really wanted to give you a taste how I might ask questions from periodic table. And the first one thing is they ask from trends. After trends, there are questions. We will talk about trends in really detail, and I've got really good notes for you. So after trends, we have properties. They ask from properties. After properties, we have trends, properties, and then we will be having little chemical reactions. The chemical reactions may seem little bit like kind of how I can like perform reactions. Most students fear from reactions, but reactions are a lot easier as you're expecting. So reactions are not going to be hard. We will talk about what reactions you really need to remember and which reactions you really need to practice. From where Amitas has asked most questions, and we will just cover those. Okay, trends, properties, chemical reaction. These are the three things. Just these are the three things from where Amit is asking questions. And then there is like we have studied in atomic structure. We don't really need to know about here. Periodic table. There is like basics. Basic that I would say the basics would be our atomic number. Like let me write it with Z. That will be like very shorter. So you need to know about atomic number, atomic mass, isotopes, how to find our molar mass. All these basics will be included, and we have already done in different chapters. So we don't really need to do it here. Here we will talking about specifically periodic table. We will understand first the periodic table. As you guys know, we have already done that little bit generally. So this periodic table has got 4 blocks. The first block is going to be this S block. The second block is going to be the P block. The third is D block, and then we have F block. So we will cover all these blocks. We need to talk about now. We need to talk about trends in S block, properties of S block, chemical reactions of S block, and then similarly P block, D block. We need to cover that. And the good thing, you from F block there is nothing. There is like a really bad or the worst thing that nightmare is there are complexes, but IMAT does not got complexes in its there's right now the syllabus we have got till now. Complexes are not part of that, so you really don't need to do the complexes, and it complexes has got a nomenclature as well, so that is also excluded. So we will not be talking about them. Although I have made the notes, but I won't because we won't be doing that because it's not part of your syllabus. So F blocks is kind of excluded. You don't need to do F block. The important 2 blocks are S blocks, from where Amit is asking most questions. After trends, okay, we will do trends generally for electronegativity, for ionization energy, and atomic size, and then we will move on to electron affinity. These 4 trends will apply to all the overall atomic table. Periodic table, overall periodic table. But then we will go into S block and we will do it individually. We will separately apply the trends as well because there are some exceptions that you need to know as well. Although haven't asked those kind of tricky questions. Okay, now, so here we go. We have got, okay, we will talk about, sorry, F block is excluded. So we will talk about the properties of S block, and there are little exceptions that you really need to master, and we will talk about them. After that, we will move on to D block. So S block and D block are really important. In P block, there is nothing except the halogens. So you really need to know about halogens. But when you will study about the trends generally, that will apply to all of them, and you can like get everything out of that. So it's not going to vanish. So now let's start with our first of all, we are going to talk about trends. Okay, before moving on, let's talk about the little bit general features of periodic table. So the first, okay, these two these two periods, these two groups make our S block. What does that S block mean? We have done in electronic configuration during our quantum numbers after we did our quantum numbers during atomic structure. So we have done that. Their electronic configuration will lie in S subshell, right? I hope you guys know. So that's why all of these are from hydrogen to francium, from beryllium to our radium. All these will be having electronic configuration ending in our S subshell. And then similarly for P block, it will be having P subshell. And then for D, it will be having D. And then for F, it will be having F subshell. So this is how our periodic table is categorized. Now, I don't know about you, but how you have studied the like groups. But let me tell you how you have studied the group, because studying group is really important. The way or the order that you have studied. First, we have got this is our like 1A group, right? 1A. Let me do it with red. This is our 2A. And now, most students say this like the D block transition elements is the scandium is going to be our 3. But I won't be saying that because we have to take this group as 3A and this group as, let me write it, 4A, then 5A, then 6A, then 7A, and then this would be 8A. Now, if you have studied this way, this is the group number 1, this is the group number 2, this is the 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this goes 13, and this goes 14, this goes 15. Instead of 5A, you say, because this like this is also written 13, 14 is also written. So instead of 6A, it is, you say it as 16, and this is supposed to be a 17, and this is for 18. But the thing here, important thing is, remember this, the 17 or 7A are our halogens, right? These are our halogens from fluorine, what is it? Our bromine and iodine, and then this is our rare element, so we won't be including it. Just forget about this element. Okay. So we have got then there is like others then. Most students say you have to remember the element names as well, specifically in periods. And now I would tell you, you really need to know about two periods, the second and the third one. I'm going to because we will be studying all of these three. So if you can understand these three, that it will be lot easier for you when it comes to ionization energy trend, because in 2023 they asked from ionization energy, in 2024 they asked from ionization energy, and in 2022 they asked from ionization energy. So if you know about these two trends, although it will apply like it is going to what will happening in periods and what will be happening in groups, that is going to stay same. But if you can remember these element names, it will be more easier, because IMAT has asked specific elements, what will be the most and what will be the minimum, or what will be the max, or what will be the minimum ionization energy. So it has got some like elements. Then if you do not know about elements, you cannot mark that question right. So that's why you have to be having some like kind of I would say two periods in your mind that will make kind of like everything easier for you. And then first two groups are important for S block, and for D block, you don't need to remember anything for F block, but there are certain elements which are fully filled and which are half filled that you have to know, because their properties will be different. And then what are typical transitional element and what are non-transitional element. Okay, so this is like a basic thing, and then there will be reactivity order. Reactivity order is important, and we will mostly do reactivity orders in our organic chemistry, because there it will make more sense when we will be reacting halogens with our like different reaction. When we will be doing different reactions, then at that time you need to know about reactivity order. So from specifically from periodic table, IMAT does not ask reactivity orders or like the acidity or basicity. IMAT asked from ionization energy, electron affinity, electronegativity, and that is what you need to know right now. So I hope you guys have a little idea about which is S block, which is P block, and which one is D block. D block are all transitional elements. Okay, transitional elements. Now, why they are transitional elements? Why we say them transitional? And these are typical transitional elements, not transitional. They are outer transitional elements, and the F block are our inner transitional elements. Now, why we say them? This is what you need to know, because one time I might have asked about these outer and inner. So that's why you should be having this. So the whole purpose of today's lecture is you should be having, because you can study periodic table really, really in a good way, more than the way I will be teaching you. But the thing is, you should be having an idea how question will appear in your exam. So the whole thing that you need to get from this lecture is the way of I'm asking the questions. So that will be like a main agenda. Okay, now let's start with our trends. Our trends. The first trend would be, although I have written the chemical bonding because I used to teach in chemical bonding, but anyways, let's write this as trends. Okay, what will be happening? The first thing, we have got atomic size. We will be very quick because these are very easier. That you have to be really active, because we need to make sure we have enough time to study our S block, P block, and D block, because those three blocks are important. Okay, the first trend goes for atomic size. What is atomic size? Basically, we have studied about bond length. What is bond length? The length of the length between two bonded atoms. Distance between, this is the nucleus of first atom, this is the second atom, these two are bonded. The distance from this nucleus to this nucleus is known as bond length. This is bond length. But what would be the atomic radius? Atomic size or atomic size, let's say. So we really need to, IMAT will be asking you trends from atomic radius. Like if we move from left to right, atomic radius increases or decreases. If we move to from top to bottom in group, the atomic radius increases or decreases. But IMAT will be asking you some reasons as well why this is happening. And then there are two radius, cation and anion radius, that we need to study. Okay, so here we go, atomic radius. So now what is the atomic radius? The bond length is our atomic size. Sorry, the distance between two nucleus and outer shell of atom is our whole atomic size. But now if we need to find out the atomic radius, what would be atomic radius? This whole bond length, okay, this whole bond length, because atomic radius is radius of one atom. Like this is the A atom, this is our B atom. So we need to find the atomic radius of A atom. So how we can find that? The distance from this nucleus to the outermost shell, this is going to be the radius. This is known as atomic radius. So just divide, okay, just divide this bond length from here to here. This would be our atomic radius. So just divide this bond length with 2 and we will get our atomic radius. So here we go. This is our atomic radius. This is also our atomic radius. I hope you guys have a pretty good idea about atomic radius. Diameter divided by 2 is our atomic radius. Okay, now there are two kinds of radius, cation radius and anion radius. Now what is the difference here? Always remember, let's say this is our neutral atom. Let's take this neutral atom as hydrogen is a simpler atom. So let's take hydrogen. Not helium. Helium would make more sense because it has got 2 electrons. Because in hydrogen, if I remove 1 electron, there would be no electron remaining, and then you will be asking lots of questions. So let me do this way. 2 electrons are here, right? And 2 protons are there. So understand it really actively, because this is our neutral. It do not have got any charge, right? It is simple helium. Now let me draw an helium again. Here we go. This blue helium. Let's do it blue because it turned blue. Maybe it was cold. Now what happened? One electron has been released. Now it is just having 1 electron, and protons are 2. Protons are 2. So during neutral atom, this is now cation, right? It is cation. So helium will be having 1 positive. Let's say 1 positive because it says just removed 1 electron or donated 1 electron. Although helium is a noble gas. Got it. Now neutral atom. In neutral atom, what happens? These 2 protons are attracting these 2 electrons. So it means that their force is equal. They are cancelling out each other. That's why it is neutral. Now we are having 2 protons and 1 electron. So it means we have 1 extra proton. That's why we are getting kind of positive here. This is a main reason. But you have to get this positive, as I told you. If you do not get it, understand properly, you will do atomic number or atomic mass when they will be asking you question, they basically make either cation or the anion. Then if you do not know is anion is like have got electron or donated electron, you cannot do the question right. So here we go. Now helium has donated one electron. There are two protons. So these two protons are now attracting one electron. Earlier there were two electrons. So two protons are attracting two electrons. Now two protons are attracting one electron. What does that mean? It means this kind of atomic radius will shrink. Okay? This will shrink, right? So that's why cation radius is less than neutral atom radius. Okay, so cationic radius is less than a neutral radius. Here we go for sodium. We have got Na positive, and Na positive will have less radius, while sodium neutral will have more radius. Okay, now let's do another way for anionic radius. Now let's do it with black. Here we go. Now let's say helium got, although helium's duplet is complete, so let's take another one. Let's take helium. Okay. Helium has got it gained one electron, although this doesn't matter because helium valency is complete. But let's say this is our helium. Okay, this is our nucleus. This is first shell. This is going to be second shell. Lithium will make more sense. Let's do it for lithium. Okay. So here we go. Now let's erase it and let's take lithium because lithium has just three electrons. This is our, let's say, lithium. Now what will happen? Lithium has one electron here, two electron in our K shell, and one electron in our L shell. Now let's say we add one electron in lithium. Lithium will become what? Earlier there are three protons. Okay? Three protons are attracting three electrons. Now what happened? We added one electron. It will become negative, right? So it will be like one go here, second goes here. So now we are having two electrons. This is like 1, 2, and here we go, two electrons. So there are four electrons now. It means one has been gained. What will happen? Now there are like three protons, right? Three protons, one extra electron is there, so four electrons and three protons. Now what does that mean? That's why it is getting negative charge, right? But now electrons are more, protons are less. So what does that mean? This anionic radius, like kind of will get bigger because nucleus fold is less, right? Nucleus fold is less, and we have more electrons. So that's why the anionic radius will be greater than neutral atom. Okay, all right. So here we go. We have got Cl negative and Cl chlorine negative has greater radius than chlorine. Now there we go. Let's talk about the trends because trends are important. So anionic radius is directly proportional to negative charge. What does that mean? It is directly proportional to negative charge. If we move from left to right in periods, okay, if you move from left to right, here we go. If we go from left to right, so this is our phosphorus, right? We are moving from left to right in this way. So this is our phosphorus. This is our silicon, okay, and this is our chlorine. Sulfur, phosphorus, sulfur, and chlorine. Now what will happen? Just get this. From moving from left to right, phosphorus has 15 electrons, right? Sulfur has 16 electrons. Chlorine has 17 electrons. Now get that thing. Phosphorus will gain, right? Phosphorus will gain 3 electrons. Okay, then it's like the valence shell will be completed because it belongs to group number 5, and it can get like 3 electrons more, and it will be having how many electrons in the valence shell? Like 8 electrons will complete out. Okay, so phosphorus, we got phosphorus. Phosphorus will gain 3 electrons. It will be having 18 electrons, right? Sulfur has got 16 electrons. Sulfur will gain 2 electrons. What does that mean? Sulfur will get S minus 2. Phosphorus will get minus 3. And chlorine will get 1 electron. Then it's like it will get 18 electrons. So chlorine will have chlorine minus 1. So this is what will happen. Phosphorus plus 3. Sulfur, minus 2, minus 3, not plus 3. Sulfur will be having minus 2 because these are gaining electron. And then we will be having chlorine. Chlorine is going to gain 1 electron. So all these will be having 18 electrons. But now the question here is, which one will be having greater anionic radius? I told you anionic radius is directly proportional to negative charge. So the one which is having bigger charge, minus 3 is the bigger one. So it will be having what? It will be having greater anionic radius. Now you can see this thing. Chlorine, sulfur, phosphorus, all these have 18 electrons because phosphorus gained 3 electrons, sulfur gained 2 electrons, and chlorine gained 1 electron. So this is why anionic radius decreases if we move from left to right. And if, let's talk about cationic radius. Cationic radius, I hope you guys know. I have given like a pretty good concept. Cationic radius is inversely proportional to positive charge. Okay, what does that mean? It means that the one which will be having less positive charge will be having greater cationic radius. Okay, if we are moving from left to right in, okay, if we are moving from left to right in period, we have got like this. Let's go over here. So here we go. This is our sodium. This is our magnesium, and here we go. This is our aluminium. So we are moving from left to right in period. Now what will happen with atomic radius? Let's see. Sodium has belongs to group 1, so it means that it has tendency to lose 1 electron because in valence shell it has got 1 electron. So it will be losing 1 electron. Magnesium will lose 2 electrons. Aluminium. This is very important. This is why I was telling you, when you remember group numbers, group names by 1, 2, 3, 4, 5, 6, like the way I told you, 3A, 4A, 5A. If you can remember this way, this will be a lot easier. This will be telling you aluminium belongs to third group, so it means that in a valence shell it has got 3 electrons. This is how everything will be a lot easier if you can study this way. Okay, aluminium has got, so aluminium can lose 3 electrons. Now just see us. And cationic radius is inversely proportional to positive charge, right? So let's go over here. Cationic radius is inversely proportional to positive charge. The one which is having less positive charge, which is sodium, will be having the greater cationic radius. So sodium will have more cationic radius than magnesium, than aluminium. Got it? And the basic thing is cationic radius will also decrease. Okay, will also decrease if you move from left to right in period, because sodium is having bigger one, magnesium is having less than that, and then aluminium. So cationic radius will also decrease in moving from left to right. Anionic radius will also decrease if we move from left to right in period. And the good thing is, you guys notice something here, little like this is like a really crucial thing. I got, okay, these 3 elements belongs to P block, right? These 3 belongs to P block, while these two belongs to S block, and aluminium is also metal. Aluminium is metal, right? So these 3 have got like, they are donating the electrons while these are accepting the electron. What does that mean? It means that metals are electropositives because they will always lose electron, while our P block elements, this is like a really good concept. P block elements are our electronegative. What does that mean? They will gain the electron. So that's why we are writing sulfur is gaining 3 electrons. So, sorry, phosphorus is gaining 3 electrons. Sulfur is gaining 2 electrons. Chlorine is gaining 1 electron. This is how, if you study the periodic table this way, and you can easily solve all the questions, right? Okay, so this is the way of IMAT asking question. This is how IMAT is asking question. Although IMAT didn't ask from atomic radius this way, but it asked from for ionization energy and electronegativity. Okay, what is the maximum? So all these elements, there are different elements. Which one will be having maximum radius? So what I told you, these are all the anions. So, and IMAT won't be asking you all the anions. Okay, it will give you neutral, it will give you anions, it will give you cations, then it will be asking you, give me the maximum radius or minimum radius. So we've got, as all the all are all are our anions, and the one which will be having the most charge will be having maximum anionic radius. Okay, you guys got it. And the important thing, although let's talk about here as well. So let's do the trends generally, then we will move on to that. And oxygen will be having minimum, because from left to right, anionic radius decreases, and oxygen belongs to group number 6, but it is above, and sulfur is below. So that's the like important concept that I really want to teach you. Here we go. So we got in our question that these 3 compounds, this is like, these are really important. So you have to study periodic table this way. And remember this, while you are studying, like doing self-study, get the periodic table and try to study this way. Then it will be making your concepts really easier. Do not do cramming. You have to do cramming, okay? Because periodic table is all about cramming. But try to understand it from using periodic table, then cram it. Then it will make a lot of sense. Okay, where I was talking. So here we go. Here is nitrogen, and here is our phosphorus, and here is our sulfur, and here is oxygen. So now it is asking which one will be having more anionic radius. So as remember this, let's talk about the general trends, then we will come on this part later. Remember these 4 elements, right? Okay. Now the general trend of atomic radius, not the anionic or cationic, atomic radius in left to right in period. In left to right in periods, the atomic radius will decrease. And top to bottom, when we moving into the groups, okay, if you are moving in the groups, the top to bottom radius will increase. Why does that happen? Why does that happen? Atomic radius, remember this, is inversely proportional to nuclear charge. Nuclear charge, what does that mean? Nuclear charge means that electrons and protons are being added into the same shell. Okay, so that's why nuclear charge is increasing. As we know that I will be telling you, don't worry. So here we go. Atomic radius is inversely proportional to nuclear charge. What does that mean? If nuclear charge is increasing, atomic radius will be decreasing. So this is what happens when we move from left to right in period. Nuclear charge increases, and that's why atomic radius decreases. I told you when electrons are being added, the nucleus, like the size will be shrinking or shrinking. So this is what happens basically. And atomic radius is directly proportional to shielding effect. What is shielding effect? If you do not, how many of you know about shielding effect? This hasn't been asked from like 5 to 7 years, but in very old IMAT they were asking a lot from shielding effect. In DMAT it has been asked a lot. Before moving on, tell me how many of you have think like I have really good understanding or basics about like exactly similar to IMAT for periodic table. How many of you think like who? How many of you believe really? How many of you have got self-belief? I'm really good at periodic table. The way I'm at ask questions, I can easily answer. And I think I have studied really good in high school about periodic table, so I think I will do all the questions right. How many of you think like, okay, I'm just asking you self-belief. Yeah, Fizan, you are right about shielding, right? Why you guys are asleep? Tell me, hurry up. We have like a lot to cover. Although we have very good time. Okay, now you got to know about the trend of our periodic table. Atomic radius. It is going to decrease if we move from this is like a very easy thing. And for ionization energy, we will study for electronegativity and electron affinity. It will be like same. Here we have to stress more because you have to get like basic idea what are the trends really. Okay, now let's go over the periodic table. Let's talk about why. Okay, why? Sorry, we need to talk about shielding effect, right? So let's talk about shielding effect. So what I told you, from left to right, when we are moving, nuclear charge is increasing. That's why the atomic radius is decreasing. Now, if you are moving from top to bottom, why radius is increasing? Because shells are increasing. Shells are increasing. So now let me tell you how shells are increasing, and then you can easily understand shielding effect. So let's say we have got here our hydrogen, right? This is our hydrogen, and hydrogen have just one shell because it has just one electron, right? Hydrogen. And now if we talk about lithium, which is like a second element in the group. So lithium is going to have one shell and two shells. Why? Because it will have three electrons, right? One electron, two electron, and third in the outermost shell. So this is, I hope you guys are understanding. Okay, if we talk about sodium, okay, sodium. Now just see this thing. So sodium is really good. This is nucleus. This is first shell. This is our second shell, and now it will have third shell. What does that mean? It will be having two electron in first shell. Let me do it red, black. It will be like more visible. Two, and the second shell will be having eight electrons, and the outermost shell will be having one electron because the atomic number of sodium is 11, right? Okay. Now what does that mean? See this thing. Now we are moving from top to bottom in group. In hydrogen, we have just one shell, right? In lithium, we have got two shells. In sodium, we have got three shells. So it means that shells are being added. Now, what does that mean by shielding effect? So now you can see, okay, this is the outer electron. One electron is outside present. And now these are the 8 electrons, right? Remember this always. These 8 electrons, let me zoom it. So these 8 electrons will be attracted by our protons, right? There are protons present in the nucleus. So these protons will be attracting like all the electrons. But now what happens? These 8 electrons are arranged in our L shell, right? L shell. So these 8 electrons, okay, will do what? They will shield, okay? They will make a shield. They will make a kind of this, like, let me do it with black. So all the electrons will kind of make a shield. All will be arranged in a shell. So they will make a shield. And now this outer electron, this is the outer electron, it has got less attraction, okay? It has got less hold. So these protons will be attracting it less. So this phenomena is known as shielding effect, where outer electrons are being shielded by inner electrons from nucleus fold. So this is known as shielding effect. So what does that mean? If we are having, okay, let me do this here. So if we are having more shells, okay, more shells, increase in shells leading to increase in shielding effect, right? So shielding effect. Now due to shielding effect, what will happen? We can easily, okay, we can easily remove this electron with less energy because nucleus hold is less on this outer electron. So what does that mean? Its ionization energy will be less. Now, what is ionization energy? Don't worry right now. So its ionization energy will be less. We can easily remove that. Okay, now you guys got it. So this was the trend of our atomic radius. Now let's go back over the question of an ionic radius that we had got. So here we got the four elements: phosphorus, nitrogen, sulfur, and then oxygen. So it is asking which is having maximum radius. We told it phosphorus will be having maximum radius, and then oxygen will be having maximum minimum radius. Now why we told this? Why? Now I told you anionic radius will be decreasing from left to right, and ionic radius will be increasing from top to bottom. This is like according to general trend. Okay, now let's go back. What I really want to teach you is nitrogen and phosphorus belongs to one group, and oxygen and sulfur belongs to one group. What does that mean? When we are moving from top to bottom, the anionic radius is increasing, right? It is increasing. And when we are moving from left to right, it is decreasing, right? It is decreasing. Okay. So what happened? It is asking about maximum atomic radius, maximum anionic radius. So nitrogen does not have maximum radius. Why? Because it is at like it lies on the top in the group, while phosphorus lies below. So this is why phosphorus will have bigger size. And now, if we are moving from in period, the atomic radius will be decreasing in period. So sulfur will have less, and phosphorus will be having more. And what will be having with nitrogen and oxygen? Remember this: the, from period, if you are moving from left to right, the one that is lies at the like the top right corner will be having the least one. So that's why phosphorus is having maximum, because in group it is increasing, and then in period it is decreasing. So phosphorus lies at like the prior. Now if it is asking about this acetylene, then acetylene would be having more radius, okay, more anionic radius, because it lies more below in the group. So this is why you really need to understand the all these things, and IMAT will be asking you by making a mixture. Okay, so now let's talk about ionization energy. Now we will be quick because we have got little idea about what are the trends. So ionization energy will be have the same trend. So what is ionization energy? Energy required to remove an electron from gaseous atom. We need to remove an electron from gaseous atom. So that will be known as ionization energy. We have got gaseous atoms. Let's say hydrogen. Okay, we have hydrogen. So in hydrogen, we have this nucleus, and then this is our first shell. Now we have one electron in it, right? So if we are going to remove this electron, right? We need to remove this. So the energy that will be required to remove this electron is known as ionization energy, and hydrogen is a gas, right? So ionization concept applies to gases, and now the trick is here. It will give you solids, liquids, and gases. Then it will ask you to identify it. Okay, so this is why you really need to be cautious. Okay, it is an energy, so it will be measured in kilojoules per mole. And remember this, it is endothermic. Endothermic means that we will have to supply energy. We will have to supply energy. So ionization energy is always, this is an important one, because there is a difference between ionization energy and electron affinity that we need to talk about in case of endothermic and exothermic. So endothermic ionization energy is always endothermic. We need to supply energy. Okay. Now, see this, we have got, let's say, 3 electrons. So let me draw lithium, right? So this is our lithium. Now this is our, let's say, nucleus. Okay, let me do it a little bit below so we can have a little more space. So this is our lithium. And lithium has got this nucleus, then first shell, and then lithium has like 2 shells, right? So in outermost shell, we are having 1 electron, and then we are having 1 electron and second electron, these 2 electrons in our K shell. Now see this. We are going to remove it always. We always be removing the electron from valence. We will start from valence because we need less energy. So now we are going to remove this electron. This would be counting as first ionization energy. Okay, first ionization energy. We remove this first electron, and now what will happen? We will be remaining with this lithium, right? This is our lithium, and this is like nucleus, and this is our shell. Now because we have removed this, so now this lithium would be Li positive. Now it has just got two electrons, right? Two electrons. Now if we remove this electron, okay, if we remove this electron, what will happen? That will be second ionization energy. This will be because we have already done first ionization energy on the valence electron, and now we will remove this. This would count as second ionization energy. Now the concept that I really want to teach you here is first ionization energy is less than second ionization energy. Why? The same concept is there. There are three protons, right? Three protons are here. So three protons are attracting three electrons. Now we removed one electron. So now what happens? Three protons are attracting two electrons. What does that mean? Nucleus hold is more on electrons. So it means that we have to give more energy to remove that electron. So this is why, yeah, the nuclear force will be more. So that's why we need to remove this electron. We will be needing more ionization energy. So similar will go with third. Now if we need to remove third electron, we will have to be having more ionization energy. So this is the thing. This has been asked in your IMAT past papers. Okay. So first ionization energy is less than second. Second is less than third one. So here we go. We got magnesium. So we are removing one electron from magnesium, Mg+1, and one electron has been removed. We supplied energy, right? And a second ionization energy, we need to remove another electron. So we remove two electrons. Okay, we remove two electrons. Now this is gone. So this is known as second ionization energy. Now first ionization energy is less than second ionization energy. Okay, now the trend is important, and there are exceptions that we need to talk about. What does trend says? If you move from left to right, and this is the most asked trend in your IMAT past papers. Trend: if you move from left to right, ionization energy will increase. If you move from left to right in group, ionization energy will increase. Okay, if we move from top to bottom in group, what will happen? Ionization energy will decrease. Okay, so this is important. Moving from left to right, why it will happen? Why it will happen? The same concept. Nuclear charge is increasing from moving from left to right in period. So nuclear charge is increasing. When nuclear charge is increasing, ionization energy is increasing. And from top to bottom, shells are increasing. So when shells are increasing, shield effect is increasing. When shield effect is increasing, what does that mean? We will be having less energy. So we will need less energy to remove that electron. So ionization energy will decrease. This is very, very important. You guys must have. So ionization energy is directly proportional to nuclear charge in left to right, and it is inversely proportional to shells, shielding effect, and size. So from top to bottom, atomic size increases. And yeah, we have talked about that previously. Okay, shells, shielding effect, and size is increasing from top to bottom. So that's why ionization energy will decrease. And electronic configuration. This is another really, really good concept. And here we need to talk about exceptions. And you can only understand exceptions if you have good concept about electronic configuration. Okay. Now we have S, P, D, F subshells. So those which are having electronic configuration in S, they will be having more ionization energy. They will require more ionization energy. Those electrons or those atoms which are ending in S subshell, electronic configuration ending in S subshell, they will need more ionization energy. Then P, then D, then F. The same thing is here because it is getting more bigger and nucleic hold is getting decreased. And remember this, S is like very near to our nucleus. We have done this in atomic structure. And then P is going to be starting from 2, right? 2P. And it will be because we have two earlier, 1S, 2S before that. So 2P will be after that. So it will be having a little more like bigger size. And then D, it will have less nucleus hold because D starts from 3D. So in between, we have got 1S2, 2S2, 2P, and 3S and 3P. Then we have 3D. So that's why 3D is a lot further in like K, L, M shell. Okay, in M shell, we have D subshell. Okay, and F lies way more farther. So that's why S subshell will have more. This is important, right? S subshell will have more electronic ionization energy than P, then D, then F. Okay, if we talk about 1s2, 2s2, 3s2, because these are same. So 1s2 is more nearer. So that's why it will be having more ionization energy than 2s2, than 3s2. Same will apply with 2p6 will be having more than 2p, 3p6, and then 4p6. So I hope you guys are understanding. Okay, now we need to talk about exceptions. What are exceptions there? As I told you, ionization energy is increasing from left to right, but it violates at 2 points. What are those points? At group number 3 and group number 6. Like if you say it's 13 or 16, whatever, and let's say boron family and oxygen family, that will make more sense. So what happens? Let's go back here and let's talk about in periodic table. So here we go. Now, the thing is, we are having lithium, this is beryllium, then we are having boron. So the main concept that says from left to right, we are moving, ionization energy should be increasing. But beryllium will be having more ionization energy than boron, instead of boron having more energy than beryllium. Okay, if we go further, we will be having our oxygen, right? So oxygen should be having more ionization energy because we are moving from left to right. Ionization energy is increasing, but this doesn't happen. Nitrogen have more ionization energy than oxygen. Phosphorus will have more than sulfur, and similar will apply to our here. Magnesium will have more than aluminium. I hope you are understanding. If you don't, let's go back and let's talk about here. We have got these elements. So this is the second period. This is the third period. Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And then we have got sodium, magnesium, aluminium, the silicon, phosphorus, sulfur, chlorine, and argon. These are noble gases. Okay, and now see this thing here. Beryllium has more than let me draw a basic. Beryllium has like more than lithium. Carbon has more than boron. Nitrogen has more than carbon. But nitrogen has more than oxygen. Then oxygen, obviously, fluorine will be having more. And this is noble gas, right? So it will be having more than that. Okay, if we talk about Na, and it will be like same will apply because left to right it is decreasing. Okay, but magnesium will be having more than that. And then same applies here, and phosphorus will be having more than that. Now, if you did not get it, in 2023, this question has been asked where neon was the right answer. I have given in the past paper question, if you guys have attempted. Okay, now just see why this happens. Why beryllium has more than boron and why nitrogen has more than oxygen. So this applies. We have in beryllium in second group, we have the s subshell fully filled, while this boron has got p in p subshell, it is just one electron. So that's why it will be more stable. While p has one electron, so it can easily be removed. So that's why boron will have less ionization energy, while beryllium have more ionization energy. And if you talk about 5 and 6a, 5a has got half filled p subshell, while our 6a oxygen has got 4 electrons in p subshell. Remember this. Remember this. Fully filled is more stable than half filled, and half filled is more stable than non-fully filled, or whatever you say. So here we go. How many electrons can be accumulated in p subshell? Right, 6 electrons can be accumulated in p subshell. Here nitrogen is having 3 electrons in p subshell. What does that mean? It is half filled, so it is more stable than p, which is having oxygen, which is having 4 electrons. So it means that we will need more energy to remove these half filled electrons, 1 electron from these like p subshell, while in our oxygen, we are having 4 electrons like this. Okay, let me do this. 1, 2, because we have 3 orbitals, right? So this is our half filled. This is half filled. This is going to be more stable. While if we talk about our half filled, this is a half filled P3. This is more stable. And now here we go, 2, 3. Now it is happening. 2 electrons are here, 1 is here, 1 is here. So these are 4. Now we can easily remove this electron. We can easily remove this electron, while we can not remove like these 3 half-filled electrons. So that's why it will need more ionization energy, while the one which is not fully half-filled or fully filled, it will need less energy. So this is the main reason here. That's why beryllium will have more ionization energy than boron. So in conclusion, 2a will be having more ionization energy, 3a, and 5a will be having more ionization energy than 6a. This is important thing that you need to remember. But IMAT do ask like these kind of tricky things, so you should be having clear-cut idea. Okay, these are the like little questions that IMAT asked, and IMAT has asked in 2023, in 2024 as well. It will give you like different elements, and then it will ask you which one is having least and maximum. So you can only answer that when you know the order of periods or the elements arranged in period or groups. So that's why you should be having clear-cut idea about that. And I told you, do remember these three, these two periods. That will make your job way easier. And in periodic table, helium has maximum ionization energy, while cesium has minimum. Why? Let's go over periodic table and see this. So cesium lies here. Okay, these are radioactive substances, so let's ignore them. Cesium lies here, and I told you from left to right, ionization energy decreases, while top to bottom it increases. So it means that it will be increasing here. And now if we move on here, so the one which is lying at the top corner will be having the least, the maximum ionization energy. The one which is lying at the start and the bottom will be having less ionization energy. So cesium is the one which require less energy. Okay, so this was the little trend about ionization energy. Now let's go over electron affinity. And electron affinity is going to be a lot easier because the trends are similar to ionization energy. But what is electron affinity? Electron affinity is when energy releases or absorbs. This is an important one. Energy will release or absorb when electron is added to gaseous atom. So either energy is going to release or absorb. There are two conditions: when energy will release, exothermic, and when it will absorb, endothermic. So when energy is going to release or absorb, when we are adding the electron, ionization energy when we are removing it, but electron affinity when we are adding it. Affinity means that kind of attraction. Electron is being attracted, so it means that when electron is being added. Okay, it is again a unit of energy, kilojoules per mole. And now the concept here is first electron affinity will always be exothermic, means negative. Exothermic means that it will be released, so it is going to be negative. And a second electron affinity will always be positive, endothermic. Let's get an example. Here we have oxygen. One electron is being added, so it means that it is going to be first electron affinity. Now we can see this. This is an exothermic. Energy has been released, exothermic, right? But now we need to add one more electron in the same anion that we have made, oxygen. Now this is an anion. Now we need to add second electron. When we will be adding second electron, now oxygen will say, nah buddy, you need to give me energy. I ain't have any energy. So it will ask, give me some energy. So we will have to give energy to add this electron to make oxygen O-2, and it will be positive. Why it will be positive? Because it is endothermic. Right? So I hope you guys got it. So this is how you should be having the little concepts. Okay, now the trends are important. So trends, what does trend says? Same as ionization energy. Left to right, electron affinity will be increasing. From top to bottom, electron affinity will be increasing. Okay. Now, what are the exceptions? This is the exception. 1A will be having more than electron affinity. 1A will be having more than 2A. Why? Because 1A is half filled. S is half filled, right? S1. While this is S2, it is fully filled. So it means that we will need lots of energy to add electron here. While electron can easily be added here because S is half filled, it has got one valency. So electron affinity. This is electron affinity, that was ionization energy. You have to differentiate that. Okay, here we go. 4A. It will be opposite of ionization energy. So 4A has more than 5A because 4A is P2, means that we can easily add to make it P3, half filled. And now it is half filled. Half filled is kind of stable, right? So it will say, oh no, I don't need one electron because I'm stable. But say we have to add that, so it will say give me more energy, right? So that's why P3 is fully stable one, so it will need kind of less energy, while 4A has got more electron affinity because it is half filled, P2. We can easily add it. Okay. So here we go, same concepts will apply. Now let's move on to electronegativity, because electronegativity is the second most asked trend in your IMAT exam. What does that say? Ability to attract shared pair of electrons. Ability to attract shared pair of electrons. Okay, what does happen when we will sharing electrons? We will make electrons when there is covalent bonding is present. So when nucleus is kind of attracting electrons more toward itself, it means that it's got more electronegativity. When it is attracting less, it means that it has got less electronegativity. So it is unitless. And trends and factors exactly similar to ionization energy and electron affinity. What does that mean? Electronegativity will increase from left to right. Okay, if you move from left to right, ionization energy, electronegativity will increase. If you move from top to bottom, electronegativity will decrease. Why it will decrease? Because shells will be added, shielding effect will be more, outer electron will not be attracted, and electronegativity is basically about attraction of those electrons. So electron will not be attractive, and this will have less electronegativity. How you are getting? And this is the important thing here. The highest electronegativity has fluorine has got the highest electronegativity. Why? Because it is at the top, leftmost corner, and why we are not including noble gases? Because noble gases do not participate in any kind of reactions, right? So what does that mean? Noble gases will not be attracting those shared pair of electron. Here covalent bond will form, right? Lowest will be having cesium. Again, why? Because it lies in the first group, in the top, left bottom. So that's why it will be known as it will be having lowest electronegativity, which is 0.7, while fluorine has 4. You should be having these things pretty clear in your mind. Okay, now let's start with our periodic table. Firstly, we are going to do S&P block. Here, I told you what we need to do. Trends are important. Mostly questions in your exam are from past exam are from trends. And second, mostly asked from little bit, not properties are not that much asked, but reactions are asked. So we are going to do reactions. I have got a little summary that will be making way more sense. Okay. Yeah, Fizan, you are right. Desperate for gaining electrons. The more electronegativity will be. Yeah. Okay. So let's start with our S and P block. We really need to understand more about S block because the reactions of S block are important. P block is not that important and it hasn't been asked, but S block is really important because its reactions are important, right? And those are really basic ones, so that's why I'm to ask from them. In P block, it never asks any reaction because there are no popular reactions. Popular are from S block. In P block, you really need to understand about oxygen. The one is the one, nitrogen is the one, and then in halogens, the chlorine is the one, very important one. So you should be having an idea. But remember this, I'm going to stress more on S block. Then you guys can do a little bit reading about P block, but it's not that much important. S block is very important. So let's talk about properties of S block firstly. In S block, although we will be doing it S and P block consecutively. So here we go. Melting point and boiling point across period from 1A to 4A. These are metals, right? 1A, 2A are in S block, and then 3A and 4A, like this one. Let me, if I, in case, because I have got periodic table here as well.
Hey, sorry for a little interruption. If you're enjoying this lecture and you're finding it valuable, then you can check out my IMAT Live course where I have got all these lectures because this is the recorded version from IMAT Live course, and now that live course is also available in the form of recorded lectures. Apart from lectures and quizzes, there are tons of other resources, schedule, and 1 month complete planner, and you can adjust that planner as well. Each and everything will be mentioned in the video. Go check out on the website. Okay, just continue with your lecture.
Here we go. We have got this. We can hide it when we will be discussing that. So melting point and boiling point in periods. So you can see here we have got either however, this is the first, this is the second group, and here we got this is our let me do this way. So this is our first group. First group. This is our second group. Then this is our third group. This is our fourth group, right? From 1A up till 4A, right? Which is let's take the second period: lithium, beryllium, boron, and carbon. When we are moving from 1A up till 4A, what will happen to melting point and boiling point? You can see this here. What will happen? Melting point and boiling point will increase. Melting point and boiling point will increase. Now, why? Number of bonding electrons are increasing. Do anybody have any idea about bonding electrons? How bonding electrons are increasing here? This is an important thing here. We have already done that. Okay, we have studied about lithium, right? Lithium. Then we have our second one is magnesium. The third one is our going to be, which one is boron? And fourth one is our carbon, right? Now, what does that mean by bonding electrons are increasing? That's why it's melting point and boiling point increasing. As we know, let's take carbon, as we know a lot about carbon because we have studied not right now, not yet. You have studied in organic chemistry. So carbon has got valency of 4 bonds, right? It can make methane, right? H, 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 and H. It has 4 valence electron. It belongs to 4 groups, so it means that it will be having 4 valence electron. So now you can see carbon can bond. Carbon can make 4 bonds. It means that it has got 4 bonding electron. 1 is here, 2 is here, 3 is here, 4 is here. Now in boron, it will be having 3 bonding electrons, right? It will be having 3 bonding electrons. In magnesium, it will be having 2 bonding electrons. Okay. In lithium, it will be having just 1 bonding electron. So what you are seeing here, when we are moving from left to right, bonding electrons are increasing. Okay, got it? Because we know BF3, right? BF3. So it means that it has made 3 bonds with fluorine. While if you talk about magnesium, magnesium has got magnesium, Mg, and with whom I should be making MgCl2, right? Magnesium chloride. So MgCl2 is making 2 bonds with chlorine, while lithium makes LiO with 1 bond with oxygen. So you can, I hope you are understanding. So these are the basically reactions. These are the reactions that we are going to study in a moment. So you can see number of bonding electrons is increasing. That's why its melting point and boiling point will increase. Now let's move from 5A to 6A. When we are moving from 5A to 6A, so here we go. This is our nitrogen, oxygen, fluorine. So if we are moving from like nitrogen to oxygen, what will happen? The melting point and boiling point will decrease. Why it is decreasing? Because number of bonding electrons. So up till 8A, up till noble gases, why number of bonding electrons are decreasing? Can anybody tell me why number of bonding electrons are decreasing? Why? Because nitrogen has 5 valence electron. It can make 5 bonds, right? Do anybody have an idea? And then oxygen has 6 valence electron. It can make 6 electron. It can't, right? Why it can't? Why number of bonding electrons are decreasing? The question here is number of bonding electrons are decreasing. Yeah, got it. Rimsha, perfect. Why? The number of lone pair are increasing. Yes, number of lone pairs are increasing. So here we go for nitrogen. Nitrogen has got 5. It belongs to 5th group, right? So it belongs to 5th group. So it means that it has got 5 valence electrons. Now it participates in 3. It makes 3 bonds. It can make 5 bonds as well, 4 bonds as well. But it usually makes 3 bonds, which is with hydrogen, ammonia, right? We know about ammonia. NH3. Now it is having 1 lone pair, right? Its valency is complete. Like it is making octet is complete, right? Chemical bonding. Like recall something from chemical bonding. After nitrogen, we have got oxygen. Oxygen has got 2. Oh, sorry. Why these lone pairs are making very big? So oxygen has 2 lone pairs. Why? It will be making 2 bonds. Now see this, bonding electrons are decreasing. It is just making 2 bonds. And then if you move on to our chlorine, chlorine is going to do what? Chlorine is going to just make 1 bond. What it will be? NaCl. So you can see here, NaCl, it is making just 1 bond. It is just making 1 bond. So here it is making 3, 2. Now it is decreasing. So that's why. And then we will move on to noble gases, right? Noble gases in neon. Neon will make 0 bond. Yeah, got it? So this is how, like everything is interconnected. You have to understand, you have to study periodic table this way. Okay, this is why melting point and boiling point will decrease. Mark it. Okay, this is S block, and we have studied for S and P block both. Now let's talk about group. That was from in period. Now what will happen in group? If you move from 1A to 2A, from top to bottom, this is S block, right? This is S block. 1A to 2A is S block. If you move from top to bottom, melting point and boiling point will decrease. Why? Because size is increasing and there will be loose packing. Why loose packing? Shielding effect is increasing. Shielding effect is increasing. That means that the nucleus hold will be less. So that's why size is being increased, shielding effect is increasing, loose packing is there. So melting point and boiling point is decreasing. You can easily get this. Make a physical or conceptual concept. That's why what is melting point and boiling point? If the thing is going to be more hard, okay? If thing is going to be more hard, if melting point and boiling point is going to be really high, when the thing is like going to soft, yes, you can take it as like mercury. Mercury is very soft, so its melting point is way more, like 25 degrees centigrade, while the glass would be 1300 degrees centigrade or 3600 degrees centigrade. So I hope you guys are understanding. So the more the thing is tough, and now it is saying when the size is increasing, there is loose packing. When loose packing is there, what does that mean? It's like kind of softer. The melting point and boiling point will decrease. So kind of make like physical or logical concepts as well. Okay, now let's talk about if we move from 7A to 8A. This is halogens and this is our noble gases. If you move from halogens to noble gases, what will happen? Top to bottom, okay, in groups. You need to make from halogens top to bottom and noble gases from top to bottom. Melting point and boiling point increases. Why? Because size increasing. Size is being increased, but London dispersion force is increasing. Why London dispersion force is increasing? Can you guys tell me why London dispersion force is increasing? This is so beautiful concept linked to one trend that we have like just studied. Why London dispersion force is increasing? It is due to electrons, right? I have already told you. Literally, I have already told you while we were studying trends. Anybody have any idea? Are you guys asleep? Speak, wait. Whatever you have got, just say it. Just say it. There is no like true and false, correct or wrong. Polarity increases. No, polarity does not increases. What will happen is, remember this, I told you, P block is more electronegative, right? P block is more electronegative. S block is more electropositive. What does that mean? They are metals, right? While the halogens and noble gases are our electronegative elements. So they have got more electronegativity as compared to S block. So that's why they will be having kind of more electrons will be there, right? But they are more electronegative as compared to S block. So that's why their London dispersion force will increase, because that is due to electrons. And now they are electronegative as compared to S block. So that's why they will be having kind of more London dispersion force. And London dispersion force is due to electrons, right? Okay, now we have little good concepts, and this is what I don't know I have written. The trend, trend. You don't really need this thing, but if you want, you can understand this. Firstly, from we have got from our I don't know this trend belong to it because I have written mixed one. I forgot it. What I have written here. Phosphorus, chlorine, and argon. I've got like maybe this is our melting point and boiling point, but just get it, just ignore it. We don't really need it because we know general one and they won't be asking you anything here. Okay, if you talk about electroconductivity, okay, electrical conductivity, this makes like very clear concepts. What does that mean? The first thing that comes to our mind is metals are conductive, right? They will be doing conductivity. So S blocks, and then there is the third group where we have aluminium present, right? Aluminium is there. And so sodium, first group is alkali metals, right? Alkali metals. And second group is alkaline earth metals. Again, alkaline earth metals. In third group, we have aluminium, and rest are all non-metals. Okay. Electric conductivity will increase when we are moving from first A to 2A to 3A in third period. Sodium, magnesium, and aluminium. Electric conductivity will increase. Why? Number of free electrons are increasing. So we know this is the like a property of metals. We don't need to like remember this. Whenever it is, you have to get this thing. S block is metal. P block is mostly non-metals. Okay, where we have got aluminium, then germanium, which have got like dual characteristics. What is known as metalloid? It is a metalloid, germanium. Okay, let's go over periodic table, and here we go. There is our germanium. So this is our germanium, and germanium is metalloid. Like it has got properties like what is that? Our non-metals and metals in both. Okay, so that's why it will be having metalloid. But remember this, you just need to remember it for S block, which is alkaline earth metals, and then alkali metals, alkaline earth metals, and then in our third shell we have got some metals. Aluminium is there, so that's why they will be having electrical conductivity, and it increases from left to right in period up till 3A, and this is the like this third period where this is happening. And in alkali metals, from top to bottom, if you move from top to bottom, conductivity will increase. Why? Because electropositivity is increasing. Electropositivity increases, and the second thing, they will be having more free electrons top to bottom because they are all metals, so they will have more shells being added, so more free electrons will be there, and electrical conductivity increases from top to bottom. Okay, we have got this here. So let's do this here, then you can easily understand. So this is group number 1A, alkali metals. Let's do it easily. So we know that lithium, thorium, and then we have potassium, rubidium, and cesium. So this is the like order. Now, what will happen? We do not take hydrogen. Why we do not take hydrogen? Hydrogen is a gas, right? Hydrogen is a gas. It's not a metal. So that's why we like separate it out from like our all the things. Right. So we have lithium, which is a metal, sodium, potassium, rubidium, and now we need to do it's all the trends. What will happen if you move from top to bottom? Number of shells will increase. Okay, top to bottom, number of shells will increase. We will come on this later, but let's talk about here. Top to bottom, if we move top to bottom, what will decrease? Melting point, boiling point will decrease. Electron affinity will decrease. Ionization energy will decrease. And electronegativity will decrease. Okay, now if you move from top to bottom, same group, we are talking about group. And if you move from here to here, right, what will happen? Number of shells are being added. Shielding effect is increasing. Size will increase because shells are being added. That makes sense. Density will increase. Density will increase. But there's a one catch in density. What is that catch? Let's talk about that. So density order. Lithium, like density is increasing from top to bottom. But the thing here is lithium, like lithium has got, okay, lithium has more than potassium. Then potassium has more than sodium. Sodium is the exception here. Sodium has kind of more density, okay, than potassium. So this is just one exception. You have to include it after that. So this is the order: lithium, then potassium, then sodium, then rubidium, then cesium. So you can get this density order because exceptions are like they're tricky ones. So you really need to get this. And now let's talk about reducing power. The reducing power from top to bottom will increase. If you do not know about what is reducing power, forget about it. But if you do not know about oxidation number, forget about it. If you do not know about oxidizing agent, reducing agent, forget about it. Because this is what really important. It's very important. It will be asking your IMAT exam and every year. Okay. The one is periodic table. The second one is our electrochemistry, and third one is atomic structure. From where every year, and the fourth one is acid bases. From here, 2 to 3 questions. Okay, if you can just prepare all these like 4 kind of chapters, your all the questions will be clear. With periodic table, you need to add chemical bonding as well because then you can identify them. And force of attraction as well. So because these all are part of kind of between atoms and those, so it like kind of all the like a C in periodic table. So if you can cover these, you are out of 15 questions, you can easily solve like 10 to 11 correct. That's like a good thing. And this is like a very good tip if you really want to work smartly. Okay, because I was just amazed. In 2023, there are 2 questions from acid bases. In 2024, there are 2 questions again from acid bases. And in 2022, there are 2 questions as well from periodic table. In 2020, there are 3 questions from acid bases. So this like make what is happening? Acid bases is like this little chapter. There is nothing. There's basic concepts and then pH. And they didn't ask from pH. They asked from basic concept. What is? We have done that. Don't worry about that. We have already done that. If you didn't focus, you have to refocus on that. Okay, electropositivity will increase from top to bottom. As I told you, electropositivity will increase. Okay, electropositivity. And electropositivity is specific to metals. Remember this. Specific to metal. What is electropositivity? Electronegativity is like attraction. Electropositivity is being like how much we can donate electron, because metal has got this characteristic. They will be donating electron to make cations. So this is why electropositivity increase from top to bottom. It means that cesium can easily donate electron. Okay. Then we have reactivity. So reactivity, this is reactivity order. You can also remember top to bottom it will increase. So cesium is most reactive, lithium is the least reactive. Okay, these are the like basic trends that you should be having in mind. Now let's talk about reactions. Reactions are important for group 1A. So from S block, the reactions are important for alkali metals. So let's talk about the reactions of alkali metals. I have got a little summary and I will be teaching you like 2-3 equations. If you can like just remember this, write down in your notes, and that you will be done with the reactions. And these reactions, guess what? It has been asked in your past paper, and this oxygen has been asked in your past paper. And then chlorine, I think there is 50% chance. I didn't say, but maybe in old one there is given. Oxygen, water are asked in your recent questions. Okay, and I have given one equation as well. Okay, so what are the reactions? Reactions, there are elements: lithium, sodium, potassium, rubidium, cesium. So now they are going to react. First, we are going to react them with water, then with oxygen, then chlorine. So what are the products that we need to know? Remember this, lithium is solid, right? All these are metals, so these will be solid. So when they will react with water, H2O, they will make a liquid. So they will make a liquid. What that will be liquid? Okay, let's get this. Lithium, all these reactions will be exactly similar. Okay, all these reactions will be same. Lithium will react with H2O, and what it will make? It will make hydroxide, lithium hydroxide, H2. You will understand more easily with the help of our sodium, because you have already know about sodium. So let's react sodium with water, what will happen? Sodium will get NaOH from our water, and it will make hydrogen gas. So they ask when with what species it will react, and it will make the product will be hydrogen gas, and that was water, right? So you should be having this idea. So I might ask this way. So hydrogen gas is being released. All these will react. This is the basic equation. Metal, which is lithium, sodium, potassium, rubidium, cesium, will react with H2O, and they will make MOH, which is hydroxide, lithium hydroxide, sodium hydroxide, potassium hydroxide, and hydrogen gas will release. So you really need to remember this statement. Yes, there is one exception that lithium and sodium will react at normal temperature, room temperature. But for potassium, rubidium, and cesium, we need to supply minus 100 degrees centigrade temperature. Okay, we need to make minus 100 degrees centigrade. So they react at minus 100 degrees centigrade. And now it is exothermic, means energy will release. Hydroxide will form. That will be basic hydroxide. We know that sodium is NaOH is the strongest base. And then the basic nature will increase from top to bottom. It means the cesium will have more basic character than lithium, then sodium, then potassium, then rubidium. So cesium will have the most. I hope you understand. Okay, so this was the reaction for H2O. It's not hard, right? Now let's talk about oxygen. What would be the reaction with oxygen? For oxygen, again, when all the metals will react with, these are in solid form. So when they will react with oxygen, oxygen is gas. When they will react, they will form a liquid. So now just see this. There will be three kind of oxide will form, like lithium oxide, sodium oxide, potassium oxide. So there are three kind of oxides can form. Do you guys know about oxides? What are there like three kinds of oxide? Do you have any idea about oxides? What are the three different oxidation states of oxygen that are possible? And all these are possible with our these elements of alkali metals, right? Do anybody have any idea? Because this is important when it comes to oxidation. Chemical, no, I don't think it will be required in chemical balancing, but it is required when you need to find out the oxidation number or something. So I think acid oxide, not oxide base. Yeah, you are right somewhere. Peroxide, another I don't remember. Okay, peroxide. Okay, there is one normal oxide. There is peroxide. Yeah, and you have the concepts. So then there is superoxide. So there are three kinds of oxides. Now there is oxidation number different. Okay, oxygen belongs to group number 6, right? So what does that mean? Oxygen can make two bonds, right? Because it will be having two lone pairs. The lone pairs, and it can form two like bonds. Let me draw it process. So it means that it will be having oxidation number -2, right? It will be having -2. When the oxygen is having, when it is bonding with just like two atoms, it will be having oxidation number -2. And this is normal oxide. Okay, normal oxide. When oxygen is bonding, okay, when two oxygens are being bonded, when it is having like oxidation number, which is basically oxidation, I'm going to teach you because I will draw a reaction for that. So when oxygen have oxidation number -1, then it will be known as peroxide. And when oxygen is having oxidation number -1/2 or half, it will be superoxide. Now let me draw for you how it will be superoxide, how it will be normal and peroxide. Let's go over here. So we are going to form normal oxide. So lithium is going to react with oxygen, and it is going to form normal oxide. Wow. Because lithium has one valence electron, it has one valence electron, so there and it is electropositive, so its oxidation number is going to be +1. You guys need to remember these, okay? +1, it will be having +1. So here we go. We draw this lithium plus oxygen, it forms Li2O. Now it is normal oxide. How? You can see here Li2O, and now here we are having two lithium. One lithium, okay? Lithium here is having oxidation number +1. But now we are having two lithium, so it means that it will be having +2, and oxygen will be having -2. So oxygen is in -2 oxidation state. So that's why it will be normal oxide. Now let's do it for our sodium. So sodium can form two oxides with oxygen. One is Na2O, which will be normal oxide. Now sodium can form peroxide. How? When two oxygens are being reacting with oxygen. So here we go, Na2O2. Now how it is peroxide? Sodium is going to, like, it has oxidation number +1. So we have 2 sodium, so it will be having +2. And here we are having 2. We have to, like, its sum should be 0. +2, its sum should be 0. So it means that oxygen is going to be -2. But now we are having 2 oxygens. So it means that one oxygen is going to be equal to -1 here. Oxidation number would be -1. So that's why it would be peroxide. Okay. Now let's do it for potassium. Potassium will form what? Potassium will form superoxide. Potassium is the one which is forming superoxide. Rubidium and cesium can also form superoxide. So let's react with potassium. Here we go, potassium. Potassium is going to react with oxygen and it is going to form what? KO2. Now here oxygen is in superoxide state. How? Potassium is +1, right? +1. And oxygen should be -1, right? Here it should be having -1, so its sum will be 0. But we are having 2 oxygen. What does that mean? One oxygen is equal to -1 by 2, and second oxygen is equal to -1 by 2. So sum will be +1, right? Sorry, -1. Sum will be -1. So both are half. -1 by 2 oxidation state is superoxide. This is known as superoxide. So this is how there can be 3 oxides can form, and this has been asked in your exam. So you should be having a clear idea. Normal oxide will be white, peroxide will be pale yellow, and superoxide will be orange yellow. And basicity, superoxide is more basic. Okay, basicity like decreases from top to bottom. So what does that mean? Normal oxide is more basic, peroxide is like kind of more basic, less basic, and then superoxide. So order would be normal, then this way, normal, then then superoxide. So should be having this in mind as well. Okay, these were the reactions with oxygen. Now let's talk about chlorine. So what is going to happen with chlorine? Chlorine, again, is a gas. It is going to react with our solid alkali metals and it is going to form a liquid. Okay, let's talk about that liquid. What liquid is going to form? So we have chloride. Okay, chloride will form. Now let's see. Lithium and sodium will react slowly with our chloride, and potassium, rubidium, and cesium will react fast. Why they will react fast? Because they are more reactive. We have studied this. Reactivity increases from top to bottom. So you should be having this in mind, right? Okay. Now, lithium is going to react with chlorine and it is going to form lithium chloride, LiCl, because it should be +1 and it should be -1. And chlorine is basically -1. And then we have like same reaction where all and cesium will be reacting with chlorine and it will be forming cesium chloride, same. But the thing that you have, that you should get from here is lithium is maximum covalent. It is more covalent, okay? It has got more covalent character, while cesium chloride has got maximum ionic character. What does that mean? It means that top to bottom, if you move from top to bottom, the ionic character for chlorides, okay, lithium chloride, sodium chloride, when chlorides have been formed, so lithium will be having maximum covalent, okay, covalent character will decrease from top to bottom, and our what is our ionic character? Ionic character will increase, okay, ionic character will increase from top to bottom. What does that mean? Cesium chloride will be more ionic, while lithium chloride will be less ionic. While lithium chloride will be more sort of covalent, and cesium chloride will be less covalent. So you should be having this idea. That's all. Nothing else. Okay, now these were the reactions you need to know about H2O, O2, and Cl2. Okay, now let's talk about group 2. So for group 2, we have these elements: beryllium, magnesium, calcium, and strontium, and barium. Barium is again little bit reactive, radioactive, and that's why we will be having fewer reactions. But anyways, beryllium have got maximum boiling point and melting point, but there is just one exception. Instead of barium having minimum boiling point and boiling point, because as we know that from top to bottom, the melting point and boiling point decreases. Instead of barium having less or the least melting point and boiling point, magnesium will be having least boiling point and melting point. This is the exception that you should be having in mind. While beryllium will be having maximum. The same will go beryllium, then calcium, then strontium, then barium, then magnesium for boiling point and melting point. Okay, now First reaction is going to be with our H2O. Let's do it with red. The first reaction is going to be with water. Okay, beryllium will react with water. There will be no reaction. Beryllium can't react with water. So magnesium can react with water. When it will react with cold water, it will form magnesium hydroxide. Now you can see that in our alkali metals, there was just NaOH was forming. But here like two OH are there. Why? Because magnesium has got the valency of donating 2 electrons. Okay. It means that it can donate 2 electrons and it can form like magnesium plus 2. Its oxidation state can be plus 2. Why? Our alkali metals has oxidation state plus 1. These oxidation states are very, very important. Okay. Magnesium has got plus 2. It is going to react with water and it will form magnesium hydroxide, MgOH, whole twice. And then hydrogen gas is going to leak. Same. Alkali metals are reacting on alkaline earth metal. Hydrogen gas is like a thing that will be forming. Okay, this is known as milk of magnesia, and it is given. It is given when you have acidity in stomach. Okay, when you have acidity in stomach, when your proton pumps are pumping more protons, HCl production is more, and you are kind of feeling acidity in your esophagus because your cardiac sphincter is opening, and that there is like kind of antiperistalsis. A little bit HCl is moving up to esophagus, not whole HCl will move out, although that solution gastric juice will move, so you will be feeling acidity. So for that we need, okay, we eat actually. There are like syrups available, there are powders available in the form of medications that we take this magnesium hydroxide, this milk of magnesia, and that lowers that acidity because it is going to do neutralization reaction and it will make water and salt. So that's why it will decrease our acidity. Okay, then magnesium and water. When magnesium and water is going to react with steam, okay, steam, very, very hot water, what will happen? We will form magnesium oxide, MgO, along with hydrogen gas. Same. And then for calcium, strontium, and barium, they will react and they will be forming hydroxide similarly, and they will be reacting with cold water. Okay. So hydroxide forms, which will be basic, that will be basic, and it will be exothermic. Energy will be released. Now let's react with oxygen. So when alkaline earth metals will react with oxygen, oxide will form. What oxide is going to form? Amphoteric is the first one, which is beryllium oxide. So oxygen reacted similar way. We formed our oxides, not normal oxide, peroxide, everything. Here normal oxide will form. Okay, here normal oxide will form with two. Beryllium and calcium will form normal oxide, while strontium and barium will form peroxide. You can see here beryllium plus 2 and oxygen minus 2. So here we go normal oxide, and here we go strontium. Strontium is plus 2, and here we are having oxygen, 2 oxygen. One is having, like we need to get here, but 2 oxygen are here, so it means that one will be minus 1. So minus 1 is going to be peroxide. The same goes with barium oxide. Okay, only beryllium oxide is the amphoteric, and it is more covalent, while all other are in basic, and all other will be basic, and all other are ionic. Okay, they are ionic. Only beryllium oxide is covalent. They can ask you, but these are like, I don't think they will be asking. But anyways, you should be having this. Okay, now let's react them with nitrogen. What will happen with nitrogen? Beryllium reacts with nitrogen and form B3N2. It is covalent and volatile, while barium will react with similar way, and all will react. Beryllium, magnesium, all will react in the similar fashion. Magnesium, Mg3N2, and calcium will react in the same way. Ca3N2, the same way. Ca3N2, and then strontium will react in the same way. So all will react with same stuff. But now beryllium is more covalent and volatile, while barium will be more ionic and non-volatile. So what does that mean? It means that top to bottom in group, our covalent character will decrease and ionic character will increase. Okay, got it. Now let's talk about chlorine. So let's do the reaction with chlorine, which is our fourth one. So chlorine is going to react with our alkaline metals, and it will form our chlorides: beryllium chloride, magnesium chloride, calcium chloride, barium chloride. You can see here beryllium is reacting with chlorine and it is forming BeCl2. So it is going to be again covalent and top to bottom, covalent character will decrease and ionic character will increase because barium's fluoride will be ionic. Okay, so this is like same thing. All will react with the same fashion. Magnesium chloride, calcium chloride, our strontium fluoride. Okay, so same fashion, same fashion. Okay, now we got to know about group 3. Although group 3 is not important, but let's do this. Let's do it quickly. So we have got boron. First is the boron, which is non-metal. At top, boron is not metal, while aluminium and this is gallium, indium, thorium, all these are metals. Right? All these are metals. Only boron is non-metal. Reactions of aluminium are important, very important. So it will react with oxygen and nitrogen. And when aluminium is in pieces, it will react with oxygen and it will form aluminium trioxide. While it is in powder form, little powder, very like small powder, it will react with oxygen and it will form aluminium trioxide. But this reaction will not be limited. It will be unlimited. Means that all the aluminium will be converted into aluminium trioxide. But when it is in like big pieces, it will like this reaction will be limited. All aluminium can't react with oxygen. Okay. For aluminium, 2 and 2. And can anybody tell me why in the form of pieces all this reaction would be limited? Because I got to remember from my high school. Why this would be limited reaction? Do anybody have any idea? It's a really good one, and this is really logical. If you can like have really good logic. Do anybody have any idea? No idea. Nothing in mind at all. Ah, yeah, got it. Yeah, I'm sure you have pretty good concepts. Excess oxygen, limited aluminum. No, that is not the case. Oxygen is unlimited in the environment. So what is happening? Have pieces, right? Let's say this is our like first piece. So what will happen? Outer surface will be converted into aluminium trioxide. Okay, aluminium trioxide, and now this will protect the inner surface. So it means that inner all the aluminium will be like safe. It will be like safe. Okay, all this like the shared one will be safe. So that's why it will make a kind of coat. Okay, this as Nisha said, so it will make a coat on the surface of aluminium and rest inside core will be protected. Okay, when it is in powder form, we don't need. Okay, there can be every single molecule of that powder will react and it will like make aluminum trioxide. Okay, other non-metals will react with aluminium like sulfur, phosphorus, and carbon. They will be making these reactions. Aluminium phosphate, Al4C3 and Al2S3. So these are the reactions never asked, but these equations can appear because for barium, from alkali metals or alkaline metals, they ask mostly. From P block, they don't ask anything. So that's why you can have a little good information about this P block because group number 3 because there is something. While for group number 7, you just need trends. In trends is important because their reactions are all covered. That will be chlorine is forming chlorides and the similar fashion that will be reacting. But you just need to know about their electronegativity trend, and then you just need to know about reactivity trend. Okay, now reaction with acid and base. So aluminium is amphoteric. It is amphoteric nature. It can react with acid. It can react with base. So these are the reactions that you should be having in mind, especially not for this thing, for acid and bases. In past paper exam, this has been because I told you in earlier IMAT they were giving you tables and there were lots of compounds were written and they asked you to pick up which are the acids, which are the bases, and which are the amphoteric. So you have to mark them out so you can like remember these. If you remember the periodic table like really good way, then you can easily mark which are amphoteric and which are like blah blah. Anyways, now there is the diagonal reaction. This is like a cool one, or I would say a puppy point. This is a puppy point. So what do I mean by puppy point? Puppy point is like a cool point. Okay? Whenever from now on, there will be any point, do remind me this is our puppy point. So this is diagonal relation. Diagonal relation says what? Diagonal relation says we have like these two periods, second and third. So this diagonal relation says lithium and magnesium, boron and aluminium, beryllium and aluminium, boron and silicon. This is silicon, right? Okay. And calcium and phosphorus. These diagonals will have close values of electronegativity, stability, melting point, and Bell point. So this is like a puppy point. We should be remembering it. If you go over periodic table, and let me write from periodic table. So let me tell you what do I mean by that. Okay, we have this periodic table. In this periodic table, you can see where is our, this is, although this is like separate out. So beryllium, okay, lithium with magnesium, and then our beryllium with the aluminium, and then boron with silicon, calcium with phosphorus. So these will have like nearly equal, not equal, same, like very, very close values of electronegativity, melting point, boiling point, and stability. So you can have this mind. And when, like, if you remember this important thing, you can like solve a tricky question when there are like lots of things that are given. And if you know this thing, if you know this diagonal relation, you can easily solve it. If they say which one will be having like very close values of everything, so you can easily do that. Anyways, so now I would suggest you to study about halogens trends. About there is nothing in halogen trends. All those basics, sorry, the basic trends that we have studied will apply here. But you should go and give a one proper read from A levels. That will be like will be to find. Now let's talk about D and F block elements. So what are D and F block elements? These are known as transition elements. Okay, let's go to our periodic table and let's see our periodic table. So let me do it here. So this is our periodic table, and now I will not draw because this will make a mess. um, we studied this S block, right? This is our S block, and we studied this is our P block. The trends will be same, nothing is there. And now we have got this much from here to here, and then here to here. This is our D block. Okay, this is our D block. Let me write it, and then I will erase it. This is our D block, and this is our F block. D block and F block. Now we need to study them. These are transition elements. Why do they known as transition elements? Why they known as transition elements? First thing, they lie in the middle of the periodic table. Okay, left side S block, and then transition is like a kind of mid portion. So these make they make the mid portion. So that's why these are known as transition elements. Now they are not known as transition elements; they are known as transition metals. And now you can easily remember from here as well. They have got here, okay, these blue ones, all the transition metals, which are D block, and then post transitional metal, post, okay, which is, I don't know what is it written, but anyways, it is maybe post transition metals, whatever it is. The pink one are post transition metals, like the after. So these one are like after the transition metals. So this is why these are known as post transition metals. Okay, now this lanthanide and actinide series. This is F block. This series is known as lanthanide series, and this is known as actinide series. And this is really important. We will talk in a moment, but lanthanide and actinide series is our F block element, and lanthanide and actinide series is known as inner transition elements. Why they are known as inner transition elements? You can remember this way. Deep, then first is S subshell, right? Then we have P subshell in way of our electronic configuration. Afterwards, we have D and then F subshell, right? So F subshell is kind of buried deep inside. So that's why maybe it is known as inner transition elements. But this is not like a proper logic. We will talk about the proper logic in just 1 minute. Okay, now we need to study D and F block. Let's go with that because we have limited time. So let's go then. Okay, now the one important thing, this is our, like, you need to know in D block elements, you need to know about this series, which is 3D series. Okay, then or this period is fourth, right? This is fourth period because this is fourth period. But this series is 3D. Why this is 3D? Because we will talk about electronic configuration. Electronic configuration is important here. So they will be having electronic configuration in 3D subshell. Okay, if we talk about our fifth element, fifth period, this fifth period will be having, this is 4D one. So it will start from yttrium. And then we have sixth or six, yeah, six, it will be 5D, and it starts from our lanthanum. Although lanthanum is a part of lanthanide series, but lanthanum is included in D subshell. Okay, it is part of transition elements of D. But we will talk in a moment. Don't worry. And here we go. And then there is seventh period, which is 6D, and which will start here. But you will just need to know about these two periods. Okay, these two periods are going to play your major role. If you can understand from here, your all questions will be correct because all the things are included in here. Rest, nothing will be asked from these below two periods. Why? Because there is nothing important here. All the important things are lying in our these two subshells, all the properties. And the good thing about these subshells that you need to study is just the is just let's like remove it, just the properties. So you need to know about properties. You don't need reactions or anything, any crap. You just need properties, and properties are important one. Okay, D and F block. Why these are known as transition elements? Because these are elements having partial filled D or F orbitals. Partial fill. When we say partial fill, these will be transition elements, and they will be have properties related to transition element. When they are fully filled, they will not be having, those will be known as non-typical transition elements. Why? Because they will not be having same characteristics. So let's talk about that. We have outer transition elements, we have inner transition elements. Outer transition elements are D block elements. This is really confusing. Most will confuse it. The outer is F block because it is separated out. No, outer is the transition elements, the D block, while inner one, dimple, is the F block. So you should be having this clear in mind. Okay, now series. We have 3D series, 5D series, 4D series, 5D series, 6D series. As I told you, 3D series start from our scandium and it goes up to zinc. This is important one. Yttrium up till cadmium. You really don't need all the, like, you don't need to remember elements, but you need to remember the properties. And then 5D series will start from lanthanum, then we have hafnium, and then up till mercury. Okay, this is our sixth period, but now let's talk about what we need to know. The second thing is inner transition elements, which will be F block. F block has got two series, lanthanide and actinide. Each of them will be having 14 elements. And remember this D block, sorry, each D series, 3D will be having 10 elements, 4D will be having 10 elements. This is really cool. Just see this thing. How this is really cool. This is cool this way. Let me give you from periodic table. So see this. This is our S block. So this is like S block, right? This is our S block. And this is like our first period of S block, lithium and beryllium. Forget about hydrogen. Hydrogen is non-metal, okay? Gas. Lithium and beryllium. So it is S block. And S subshell accommodates how many electrons? S subshell accommodates how many electrons? 2, right? So what does that mean? You can see this, how this periodic table is arranged. Lithium and beryllium, just two elements are in the period of our S block element. Then same, 2, 2, 2. So this is all this block. And now if we talk about P block has got 1, 2, 3, 4, 5, 6. So 6, because P subshell accommodates 6 electrons, right? And here we are having 6 elements in each period of our P block. We are talking just P block, not whole periodic table. P block, okay, from here to start here to here, and then from gallium up till the krypton. So this is how you can easily remember. This is way easier, okay. And the cool thing is group number indicates the valence shell. Valence electron. This is our this is our third group, right? Barium, as I told you. So boron will be having 3 valence shell, while carbon will be having 4 valence shell. This is how you can understand periodic table, right? And now let's talk about D subshell. D subshell accommodates how many electrons? 10 electrons. Okay, D subshell. So you can see here, D series, each D series is having 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is having 10 electrons in each series. And now we talk about lanthanide and actinide series. It is having, because F subshell accommodates 14 electrons, right? So here we go. This series contains 14 electrons, lanthanide. And this actinide series contains 14 electrons. This is so cool, right? Okay, let's hide it. Okay, so let's talk about our lanthanide and actinide is done. So it will be having 14 elements and 14 elements. Its atomic number starts from 458 up till 71, and then 90 up till 103. Okay, now let's talk about typical transition elements and non-typical transition elements. This is important thing. So non-typical transition element says what? Typical transition element we need to understand non-typical, then we can easily understand typical, because we have maximum typical while we have like few non-typical. So the group 3b and 2b, what are 3b and 2b? We are going on that. Scandium and zinc in 3d series, and in 4d series yttrium and cadmium, and then 5d series lanthanum and Hg, hafnium, I think hafnium, yeah. So these are non-typical transition elements. Why they are known as non-typical transition elements? Because they do not have half-filled, partial filled, partial D subshell or F subshell. So this is why these are non-typical transition elements. Why they are still considered as typical? Why they are still considered as transition elements? Because they make complexes. I hope you guys know about complexes. So the basic or the good property of transition elements is they make complexes. Complexes are not part of your syllabus for now. So that's why we will not be talking about complexes. Although I have got all the and what is it nomenclature and all the how to make the complexes, how they make complexes, how to name the complexes. I have got that, but we will not be studying here because F block is really famous for that, and also D block. But anyways, so their properties, okay, they do not follow typical properties, non-typical transition elements. They do not follow the typical properties of transition elements. That's why they are they are known as non-typical transition elements. What are the properties? We are going to cover in detail. While typical transition elements, all other typical elements, okay, all other elements which follow or which give us the transition element properties are going to be typical transition elements. Okay, now we have two groups. We have got two groups, 6b and 1b. We will talk about from the periodic table, but these are the ones that we have already studied in during our atomic structure when we were doing Aufbau principle. We talked about chromium and copper. These are the six elements which violate electronic configuration, specifically the Aufbau principle. What Aufbau principle was saying is that it, like, firstly lower energy orbital will fill, then high energy orbital fill. But here what happens? Opposite happens. High energy orbital will fill first, and then lower energy orbital will fill first. Will fill. Why? Because there is a thing. Here we go. For chromium, the D is half filled. So that's why firstly it will fill half, then our S subshell will fill. So here you can see S is 1. The Aufbau principle said firstly S should be filling, means S should be having 2 electrons, 4s2. But here we are having 1 electron, but 3D is having 5 electrons. So it means that, what does that mean? Half filled is more stable. So that's why it will fill half, and it will take 1 electron. Instead of filling into 4s, it will fill in 3D. Yeah, because of stability. Yes, absolutely stability. Okay, now let's talk about copper. Copper has got 4s1 and 3d10. You can say it is fully filled. That's why it said, let me give me firstly electron, then 4s, like the cooperation kind of thing. And it said the next electron that will come, you can have that. So, but he deceived it. He didn't give him the electron because now he can't have the further electrons. So that's why 3d10 is fully filled. Now it is more stable. So that's why it will be accommodating 10 electrons while it is having s1. So this is why these all violates Aufbau principle. But we have W, tungsten. Tungsten does not violate it because you can see here in 5D it is 4. Instead of 5, it is 4. But in 6s we are having 2. So tungsten is the one that does not violate electronic configuration. Rest chromium, molybdenum, and then copper, then which is silver, and this is our gold. So all these violates electronic configuration. You should be having this idea. Okay. Now let's start with our properties. We will start with, we have this 3D series, okay, this 3D series, and let me get the periodic table, then you can understand more easily. So here we go, this is our periodic table, right? So here you go, this is our periodic table. Now you can see here, we can read it here. This is written, okay? This is written 3B. This is our 3B, this is our 4B, then this is 5B, then you can just see it, okay? 6B, 7B, 8B, 8B, and this is our again 8B, because in 8B we have 3 columns. This is our again 8B, and then this is our 1B, and this is our 2B. So 3B is here, 1B, 2B, 3B, and our this is 4, 5, 6, and then 7, and then 3 8Bs. 3 8. So you should be having this like clear how these are arranged. So that's why I've written here 3B is having this first is scandium, then we have, I don't know, the TI. What is TI? Whatever it is named. These are like very, very bad name. Then vanadium, then chromium, then manganese, then iron, then cobalt, nickel, and 8B series having 3 elements, right? So iron, cobalt, and nickel will be there. And this is very important because these will be ferromagnetic. You can, like, this is so, periodic table is arranged so beautifully that if you can understand it like very in an order way, or kind of understand it like properly, you will be like kind of enjoying. Everything is properly arranged. You just need to get an idea. Ferromagnetic, why? We will talk about that. and 1b and 2b we have a copper and zinc. And I told you 1b and 2b, right? 1b and 2b. That's like let's move it. So we were having this, sorry, 2b, and then this is 1b. So all these 2b group specifically is our zinc. Okay, where is our 2b? This is our 2b, zinc and cadmium. These are non-typical, and 3b is also. So here we go 3b, so, scandium and yttrium. These are our non-typical, while all are other typical. But where do they violate electronic configuration? In 6b. This is our 6b because it lies in the middle. There will be half filled. Okay, half filled d orbital. So that's why it will violate the electronic configuration of Hubble principle. And then we have this our 2b, zinc and our cadmium copper will be violating this as well. Okay. Now we have got these properties. We need to study properties because properties are important for D block elements, and D blocks are really important. So let's talk about them. So we have got electronic configuration. The electronic configuration is going to be, you need to remember this, n minus 1. D will be, can accommodate electrons from 1 to 10 because the maximum electron it can accommodate 10, and minimum will be 1. And then ns will be accommodating 1. What is n? What is n? We have done that because this is why I taught you the atomic structure, something in atomic structure in very detail. So what is n? What is n? Although you can tell me it is number, but what is specifically like we did in our atomic structure? Shell number. Yeah, you can say shell number, but from quantum numbers, now in quantum numbers, we did principal quantum number. So this is principal quantum number. N is principal quantum number. Principal quantum number. Okay, now what does that mean? Okay, firstly, we are doing this our series, which is 3D. Okay, 3D series. This is 3D series, but here the group number. Okay, this is like the same principal quantum number is like a period number. So here the period is our 4, right? 4 period number. And now you can see the n would be 4 right here. And if you go for 5D series, 4D series, that will be 5th period. So we will be taking n as 5. Okay. Now let's put this in this. We are doing for scandium. So scandium would be 1s2 that will lie in K shell because K shell can accommodate 2 electrons, and here we are having 2 electrons. Then L shell. L shell is having 2 electron and 6 electron here. Why I'm writing 9 electrons? It can just accommodate 8 electrons. Okay. Now after 8 electrons, we are having this M shell. M shell is having how many electrons? 2, 6, and 1. Now, what I was about to teach you is n minus 1. So the 4 is n, right? 4 minus 1 would be 3. So here we got our 3D. That is why it is 3D, not 4D. So period number minus 1 will be equal to this D subshell. So 3D subshell is here. And now this 3D will be accommodating this 1 electron. And we are having 4s2 in N shell as well. Okay. Now we can write it as, okay, 1s2, 2s2, 2p6. This is equal to, now just this one. Okay, from 3d6 to up till here. This is equal to the electronic configuration of argon. Because argon accommodates how many electrons? 18 electrons. And here we are having 8 electrons. 2 plus 2, 4 and 10, and 2, 12, and then 6, 18. So 18 electrons are here. So we can just write, instead of 1s2, 2s2, 2p6, 3s1, and 3s2, 3p6, we can write argon because it is going to same for all the elements. So for scandium, we can write argon 18, and then we can just write 4s2 and 3d1. Then for chromium 24, we will be having 4s1 and 3d5. As I told you, 3d5 because it is half filled. So that's why it will be having 1. It is violating the Oppo principle. Then manganese, same way. And now I have a related to the electrons as well. M shell will be having 9 electrons. Then N shell will be having just 2 electrons here. The thing important here is pairing and unpairing of D electrons. So in D subshell, here we are having just 1 electron. So what does that mean? D is having 1 electron, and it is just like single electron. So here no pair is existing, right? And according to Hund's rule, when we did electronic configuration, Hund's rule says what? Our this what is it? D subshell is having 5 orbitals, right? 5. Now 5. Let's do it. 4 and 5. So what will happen? He said, first the electron will fill like this. 1 here, 2nd here, 3rd here, 4th here, 5th here. Now pairing will start. The sixth one will get pair. Here we go. Opposite spin will be there because according to spin quantum number. And then here we go. If there is 7 electrons in D subshell, so 2. Now we are having 2 pair. One is here paired, second is here paired. And here we can go if there are 8 electrons, then there can be pair. Then pair can occur here. I hope you understand it. So let's talk about how many are unpaired in scandium. So in D subshell, we are just having 1 electron. So 1 is unpaired. Nothing is paired. In D subshell, we just don't have any paired electron. Then in chromium, we are having 5 electrons. Now, I told you, firstly, 5 will be unpaired. After 5, the 6th one will get paired. This is Hund's rule, and you have to follow that for electronic configuration. So, we will be having 5 unpaired, 0 paired. And now we talk about 3d5 for manganese. Same will apply. 5 are unpaired, nothing is paired. And similarly, go with iron. Here, one pairing start, then pairing will go. And maximum 5 pairs can form because there are 10 electrons there, and 10 electrons means that there are 5 pairs. So you have to understand this pairing and unpairing for color transitions, because we are going to talk about colors. Now let's talk about binding energy. So what we need to study about binding energy. Binding energy is directly, binding energy means the power of making bonds together. Binding energy is increases when you move from 3b to 6b, 3b to 6b, and bonding energy decreases when we move from 7b to 2b. Okay, 3b to 6b. Let's go with our table. So from 3b to 6b, here we go. This is our 6b. From here to here, the binding energy will increase. Why binding energy will increase? Anybody can tell me. And if you move from here, the red line, the binding energy will decrease up till here. Why this is happening? It's pretty easy, because I explained you for 5 minutes this thing. Why this is happening? Binding energy, the same concept is applied. We did in S block, the same thing. Sorry, in SP block, the same thing is applying here. What is that? Anybody? Any idea? Any idea? Please. It is literally same. We are having up till manganese, D are unpaired. Electrons are unpaired in D. You can see here, manganese. This is manganese. 5 are unpaired, means that they can form. They can form bonds, right? These 5 can form 5 bonds. That's why it's oxidation number can be +1, +2, +3, +5. So this is a really very confusing right now. But anyways, it's pretty easy. Okay? It's pretty easy. After fluorine, after iron, just see this thing. Pairing is being started. One pair is there. So it means that now binding energy will decrease because bonding will decrease. I hope you're understanding. Okay. Up till zinc, it will be least. Anyways, it's pretty easy. It's not hard. You just have to get this way. Anyway, binding energy depends on number of free electrons. So this is a thing I really saying this. Number of free electrons. Binding energy is directly proportional to stable structure. Binding energy is directly proportional to melting point and boiling point. So the more the binding energy, more the melting point and boiling point. And maximum binding energy we have got. Sorry, vanadium has got in our transition elements, and minimum is zinc because it lies at the maximum corner. And why vanadium is more? It has got close packing, while zinc has got no free electrons. All are paired. 3d10, right? 3d10, all are paired. So that's why it will be having minimum. Now let's talk about oxidation. They have variable oxidation. This is really cool property of transition elements. Variable oxidation means that their oxidation state is due to involvement of D as well as S electrons. Okay, so common is +2, +3, but maximum it can be up to 5. Manganese is the one which is having +7. Why it is having +7? Because 3D is 5 and we have 4s1. So it means that 3d5 can form and then 4s1 can form a 1 bond. So it can go up to +7. And we have +2 for the zinc and metal. High oxidation state, which will be the metal which will be having high oxidation state, it will be oxidizing agent, which will be having low oxidation state, will be reducing agent. So high oxidation compound will be covalent and low oxidation compound will be ionic. Okay. Now we talk about catalyst. The D block elements can act as catalyst either freely in the form of elements and in the form of compounds. Okay. Why they will act as catalyst? Because they have got variable oxidation state. So they form intermediate compounds. That's why they will be known as catalyst. They will be acting as catalyst. D and S orbitals specifically take part 4s, and if you talk about 3D series, 4s and 3D, or 5s or 4D, 6s or 6D, 6s or 5d. So this is how it will be active. Now, if there can be element like nickel, which is this platinum, this is palladium, and this is copper, then this is zinc. These three. Anybody have any idea the common reaction that we do in organic chemistry where they act as catalyst? Anybody have any idea? Platinum, yeah, it is platinum. Nickel, platinum, and palladium. Where do they act? Anybody, any idea? If literally you do not know, I really need to get my head in my hands. Catalyst. In which like kind of reaction in organic chemistry? It's like that are really, really common. Yes, during hydrogenation, nickel, platinum, and palladium occurs, and high temperature will be 200 to 250 degrees centigrade. This is the like important one you should be having. Copper and zinc also act in different reactions as catalyst, and compounds V2O5, vanadium pentoxide, and TiCl3. These two compounds can also act as our transition elements. There is, I forgot the reaction. What was the reaction name? This is really like a cool reaction where vanadium pentoxide acts as a catalyst. It was a really cool reaction. I forgot it. I literally forgot it. And we do study in, although this is not part of your syllabus, but we do study in comparison form. Oh, I forgot it. Anyways, we will talk when I will remember again. I will let you know. Okay, now let's talk about magnetic properties. Magnetic properties are important. The block has got magnetic properties. What are those? They can act as diamagnetic, paramagnetic, and ferromagnetic. What is diamagnetic? What's para? So diamagnetic, if there is any external magnetic field is present, the diamagnetic, so those elements that act as diamagnetic, they will repel that magnetic field. Like there will be repulsion. So when it will occur, which element perform that repulsion, or they will act as diamagnetic? Those which have D empty or D fully filled, they will act as diamagnetic. Okay, paramagnetic. Paramagnetic means in magnetic field, they will attracted. Okay, they will attracted. Now remember this: when this magnetic field will be removed, there will be no attraction present. Attraction will be removed. Okay. Those elements which have got unpaired electron in d orbital, d subshell, they will be paramagnetic. Paramagnetic is is directly proportional to number of free electrons. What does that mean? It means that the one which is half filled, d subshell, they will be more paramagnetic. You can be asked. Okay. And now the thing here is this is very important thing, that when magnetic field is removed, external magnetic field is removed, the paramagnetism will be gone. Now let's talk about ferromagnetism. Ferromagnetism is like similarly unpairing electron. These will be attracted, very, very strongly attracted. But when we will remove the magnetic field, there will be still attraction present. So this is our 8D group, which has got iron, nickel, and cobalt. We know that they are ferromagnetic. Okay, now let's talk about sixth property, which is alloy. They make alloy. Okay, mixture of metal plus metal. This is an example of solid solution. I hope you have watched the lecture of solutions. This is important. Every single year there is one question from solution. From metal plus metal is a example of solid solution, and metal plus non-metal can also react. Can also form alloy, and that will make steel. Okay. Now, why they make alloy? Due to comparable, because they are comparable. There is no big difference in their sizes. They have got same properties, right? They have same properties. That's why we can mix them up. But remember this, in alloy formation, their chemical properties will be same, while their physical properties will change. Only physical properties like melting point change, boiling point change. Their chemical properties will be as same as. They will be metal. They will conduct electricity. Everything will be same. This has been asked in your past paper. Okay. Now let's talk about color complexes. This is the last property. Color complexes, they give us color complexes. How they give us color complexes? Due to d transition. Now, what is d transition? We know that there are different orbitals in d subshell, right? So now, what will happen? When a ligand, or you say it ligand, whatever you say, ligand is going to approach it, like let's say chlorine, it is going to approach it, they form color. They will give a certain kind of color. Any ligand, Okay, any ligand. But let's talk about in terms of light. So let's say we got light. Okay, light. In light has got like certain energy. Now when light will be fallen, what will happen? There will be d transition will occur. Like sorry, electron will move from low state, lower energy state to high energy state, or high energy state to lower energy state. In that case, let's say they will absorb energy and they will be excited. Okay, they will move into higher oxidation, high energy state. Now, once the light is removed, they will again come back to their low energy state because they need to attain that. So once when they will come back, the de-excitation will occur. They will emit a light, which will be colored. So they will give us a color. This is very important. Now, what will happen when violet light is fallen? This is like a complementary color chart that you can like remember from. So when violet light is fallen, what will happen? We will get yellow color. When blue light, we will get orange color. So, and when green light, we will get red color. So if red light is there, we will get green color. So this way you can find the colors. And now the empty or the fully filled will be colorless. Why? Because there can't be any d transition. Atoms like electrons can't jump, right? Metal which has got highest oxidation state will be usually colorless, which is our manganese, right? It has got highest oxidation state, which is our manganese, right? It has got +7. So this was all the properties that you needed to know about, our D block elements. And in F block elements, there is nothing that you need to know about. In F block, that you need to know is this thing. In F block, okay, let me go up. Let me remove it. Okay, this is the thing. This is lengthenide series, right? This is lengthenide series. Lengthenide series means that it starts from lanthanum. But remember this, lanthanum is not included in our lanthanide series. After lanthanum, we are having F block elements. All the elements that will be in lanthanum will be part of our F block elements. And then similarly, in actinide series, actinum will not be a part of our F block elements. It will be after the actinum, we will be having the F block elements. So this is like a concept that you should be having. And I don't think there is anything further. So this was all about this. And now in the F block, there is nothing like as crucial. Properties are same. That's there. The thing is they make complexes, and they are known as inner transition elements. And yeah, there is nothing more to discuss, but I would suggest go and read little like orders or reactivity orders and everything regarding to our halogens, because halogens is important, and do kind of study about noble gases as well. Although we have mostly covered noble gases, and there is van der Waals attraction in our forces of attraction we studied, and then noble gases has got the highest electronic noble gases have got the highest what was it? Ionization energy, because from left to right, and this was a part of past paper question. So let's go over past paper question, and let's do the past paper question. Okay, let's do the past paper question. So we have got this past paper question here. Let me share my screen. So we will be really quick. Those which are the part of our like kind of syllabus, we will be studying them. Let's like cover them. So the first question is which of the following compounds? Okay, which one I've shared? Which one of the following compounds from a hydrogen? Okay, if I remove it, okay, see, this is like a good screen I've shared. Which of the following compounds form a hydroxide when reacting with water? Okay, now you know that barium, right? Barium oxide when react with water, it will form barium oxide. Barium oxide when will react with water, it will form a hydroxide. Okay, this is like a good thing. And chloride, SO3, Si3, these all not will form. And this is the question from 2024, right? Okay, we talk which of the following is a gaseous compound at room temperature and pressure that exists as linear molecule. Gaseous and linear and react with water to form acidic solution. You know that. Which one is that? We will study in respiratory system. We will study carbon dioxide. Carbon dioxide reacts with water and forms carbonic acid, right? And it is linear. We talked about that. Bonds are polar, but compound is non-polar due to like dipole moment is 0. So the option A is correct. Okay, let's be quick. Which of these elements has the highest first ionization energy? I told you, move from left to right. This is from 2023. Move from left to right. Okay, move from left to right. All the like elements are same. So lithium is like above, and then neon is like at top corner and above, so it will be having the highest first ionization energy. This is really easy one. There is, we don't have to deal with these. Okay, if you know the like two like periods, second and third, you can easily solve it. Okay, that's very easy. Okay, now barium sulfate is insoluble in water. Although this is not related to this, this is more related to electrochemistry. But here barium sulfate was there, so I thought we should be adding to this. Aqueous solution of barium chloride and sodium sulfate are mixed. Which of the following explains in the we should be doing in electrochemistry? I think I have added this question as well in electrochemistry. Okay, we can do this. Okay, the first one is correct one, because barium and sulfate, when will be poured into water, they will be giving BSO4. And these are the ions. We talk about them, don't worry, in electrochemistry, because we need to balance the chemical equation, and then it will make more sense. Right now you will get confused what I'm talking about it, and it will go very big discussion because we did not have studied here. Which of the following is given the elements in order of decreasing first ionization energy? Okay, this is like, this makes sense, as I have got here. So decreasing first ionization energy, decreasing. So we have got this beryllium. Beryllium belongs to second group, right? And then we have got lithium and sodium. Lithium belongs to second one and sodium belongs to third one, right? So we need to find out the decreasing first ionization energy order. Decreasing, not the increasing. So what will be happening? We will be having, okay, because it increases in left to right in period, and sodium is below our lithium. So it means that beryllium will be having the maximum, then our lithium, and then sodium, because sodium is at little bit below. It has three shells, right? That's why it will be having this order. Firstly, beryllium, then lithium, and then sodium, because sodium lies in there. So if you know periodic table the way I explained to you, you can easily solve all these questions again. Oh, okay. I hope you guys got it. It's like questions are way easier. There is like nothing like crucial or anything. Nothing is confusing, but it can be confusing when you do not have got proper understanding of periodic table. So try to understand it. The lecture was very comprehensive, and I don't think you can easily understand the periodic table unless you do tons of practice by yourself. So get the picture of periodic table and try to draw everything. Get the ionization energy trend. Make some mnemonics for yourself. This is how you can conquer it. And remember this, from periodic table, you will be getting 2 to 3 questions, and that's why you have to study it. Okay.
I hope you have enjoyed this video. If you did, then I want you to thumbs this video up and comment down a green emoji, any green emoji, an apple or any flower, anything. It would encourage me that you have watched this video and you really care about your exam, and this lecture actually helped you. And if you want to check out more lecture like these for biology, chemistry, physics, maths, logical reasoning, each and every single subject of IMAT, along with tons of quizzes and practice questions, then check out the link in video description. Yeah, that's all. Subscribe to this channel, and you would love to check out this playlist where I have solved lots of IMAT past papers related to biology, chemistry and everything. So check out this playlist and this video if you want IMAT lectures, absolutely free resources. And if you want to go for paid, then there will be mentioned in the second part of this video. So see you in next video. Till bye bye.